Good evening, all of you. Today we are going to see about nuclear force. So, the atomic structure. So, you'll be having a nucleus, and this nucleus consists of protons and neutrons. Okay, and electrons revolve around the nucleus. This is first orbit, then you will be having the second orbit. So all these stuffs you know. Now the question is, what is nuclear force? So we are dealing inside the nucleus. So it will be having protons. Protons will be having positive charge. So if you consider two protons, both are positive, therefore there will be a repulsive force. So approximately the distance between two protons is 10 power minus 15 meter. So there is a repulsive force. So we go by Coulomb's force. So the Coulomb's force is equal to, repulsive force is given by K into Q square divided by R square. The K is a constant. The value of K is 9 into 10 power 9. Q is the charge. 1.6 into 10 power minus 19 square. The distance between the two protons is 10 power minus 15 meter approximately. So you will be getting 10 power minus 15 the whole square. If you simplify, you will be getting approximately 230 Newton force, that is Coulomb's force. Okay. Now, based on this value, we will find out the acceleration. We all know that force is equal to mass into acceleration. Therefore, acceleration is equal to force by mass. So, force we know 230 divided by mass of the proton is given by 1.67 into 10 power minus 27 kilogram. This value you must know. So, after simplification, approximately you will be getting 1.4 into 10 power 29 meters per second square. That is the acceleration. Now, this acceleration is compared with the acceleration due to gravity. That is approximately 9.8 meters per second square. So, I am approximating 8 to 10. So, if you simplify, you consider this as 1. So, if you simplify, approximately it is 10 power 28. Now, you see the acceleration, it is 10 power 28. So, what will happen? The nucleus, this nucleus will fly apart with great energy. So, this nucleus will fly apart. But it is not happening so. It is held firmly together. There is no disruption. Okay. So, how it is held together? It is not flying apart because of this very high acceleration, but it is held together. What's the reason? So there must be some other force which makes the nucleus held together, and that force is called nuclear force. Basically, a nuclear force is an attractive force. Okay. So, there must be a strong attractive force. Strong attractive force. And that force is called nuclear force. Okay. Now, this strong force is very much greater than Coulomb's force. Coulomb's force. This is repulsive, and gravitational force. Gravitational force. So this is repulsive, this is attractive. Even though if you consider Coulomb's force and gravitational force put together, these forces are negligible compared to the strong attractive force that is nuclear force. Okay. So what happens is these are very weak compared to the nuclear force. That is another point. The next point is, okay, now we know what is nuclear force. The nuclear force exhibits equal strength between proton and proton. Proton and proton, the force is same. Similarly, between proton and neutron, same value approximately. And between neutron and neutron, the nuclear forces, the value is going to be same. It is not going to differ whether it is proton to proton force or proton to neutron or neutron to neutron. So basically that attractive force is very much greater than Coulomb's force and gravitational force. Now the question is whether this force is going to affect the electrons. Definitely not, because this is happening within the nucleus and we know that it is an attractive force, it is not a repulsive force. So the electrons are totally not disturbed by this nuclear force. So a strong nuclear force does not act on the electrons. So it does not alter the chemical properties of the atom. So it is not going to affect the chemical properties of the atom. So by this we can understand what is a nuclear force, how powerful it is. Even though we have repulsive force like Coulomb's force and attractive force like gravitational force, when compared to the nuclear force, these forces are highly negligible. That's why nucleus are binded together. Hope you have understood this topic on nuclear force. Thanks for watching this video. Nandri.